Hello, my name is Darren Thomas and I am the Director of Educational Research Technique. This is Simpler Using Machine Learning Algorithms in R. We are now in Chapter 7 or Unit 7, Lesson 3, and this is going to be slightly different from other model developments. What we're going to do here is we're going to develop and test a model using linear discriminant analysis, and we're going to develop and test in the next video a quadratic discriminant analysis, and then we will compare the results of the two algorithms to see which might be more appropriate for the data set. Now please keep in mind that our goal here is that we want to try to predict sex based on different variables that are relating to math level, whether it's the number of classes they're taking in math, their math scores, etc. So having said that, let's go ahead and go over to R. So first you got to run your you have to run your libraries in line 1, set the seed in line 2, and then in lines 5 and 6 we're going to run our model using linear discriminant analysis. So I've explained this before, so I'm just going to do it quickly here. And so here are the results right here for our data. And so all this information here is the means for men and women for the different variables. Now we use these means, we use these differences here to try to set up our linear discriminant function. And then down here below we have the coefficients. Notice how we only have one linear discriminant. That's because the number of lines of discriminants are made based on the number of groups minus 1. We have two groups, men and women, so that's 2. 2 minus 1 becomes 1. That's why we only have one discriminant analysis here. And so you can see the different levels, etc. Now, having said that, why don't we take a look at the visuals? This will be a little bit easier for us to try to understand what's happening with the data, so I'm going to make that bigger. And then in line 9, we do our first visual. And so here's kind of the distribution for the males and the females. You can see that there's a little bit of overlap, which means we might have some challenges in terms of our predictions here. Now in lines 11 and 12, in line 11, we do our predictions based on our data, and then in line 12, we pull the predictions that come from the math LDA.predict, and then in lines 13 and 14, we make our table and get our our accuracy rate. So you can see here, down here in the corner of the accuracy here, so 240 of the males were classified correctly, 61 of the females were classified correctly. We have some problem with some males being judged as females, and of course some females being judged as males, etc. And then for our accuracy, we use the mean function, and we do math.train.$LDA, and then we do math.train.sex. LDA is like the prediction, that's what I called it if you look here in line 12, if you will. So we do that, and you can see we got about 70% accuracy. That sounds pretty good. And so now we're going to make a picture of the actual distribution. Now this is the training set, and so obviously, we can't put everything in the training set because we'll get a giant blob of black mass. But I chose 178 as our example because that's how many are in the test set. So it's good for comparison. What I mean by 178 is that we're taking the first 178 rows and we're going to map them on a plot to see what they look like. And so there you can see them clearly right there. There's a pretty good definition here between the males and the females. Let me zoom in for you so you can see this a little bit better. And so you can see right here, the blacks are the males, the red is the females. And so it looks like it's a pretty good separation. 70%, depending on what your goal is, could be pretty good. In the social sciences, we would normally be happy with that. So that's that's kind of what's happening with the visualization of this for the training set. Now for the test, or actually I guess you could say the validation set, we take our model we made, LDA.math, and we use now the test set, math.test, and we run our results here. Again, this is mostly review, nothing new here. And you can see right here, what's the accuracy in line 26? 59%. So there's quite a bit of a drop off. This means that we're having a difficulty using our model in a different context. It's not generalizing well. And then for the visualization, we'll just run this. And you can see here the spread of the data. Again, I'll zoom in just so you can look at this. Again, it looks like good separation, but we're not quite sure where the line is being drawn at. Often it's drawn at 0, not always, and so that might be why. But remember, we don't have all the data here, just the first 178 rows, so it won't be completely clear. But we do have some idea of what to expect. All right, and so that pretty much wraps up this video. The key thing to remember as we walk away from here is the accuracy. So on the training set, it was 70%. on the test said it was 59%. And so now in the next video, we're going to see when we do this with quadratic discriminant analysis, how it will compare to what we did with linear discriminant analysis. So in this video, we just ran a linear discriminant analysis model. This is a review of what we did in chapter 6. There's nothing really new or radical here in particular. We did the plot, we ran the model. We had to do a little bit of making a classification where we had to take some information from different places. But again, this is all mostly review. And so I'm not going to spend a lot of time talking about this. So I hope this information was useful for you. And I'm looking forward to seeing you in the next video when we do all this again with quadratic discriminant analysis. So my name is Darren Thomas. I am the Director of Educational Research Techniques. This is simpler using machine learning algorithms in R. Take care.